This is a video from section 5.1 in linear algebra. Let's take a look at example 1. Find the characteristic equations of the given matrices. Let's take a look at part A. Suppose A is the matrix 3, 0, 8, negative 1. So A minus lambda I is equal to 3, 0, 8, negative 1 minus, and then we get lambda 0, 0, lambda, which is equal to the matrix 3 minus lambda, 0, 8, and then negative 1 minus lambda. So from here, we're going to set the determinant of A minus lambda I equal to 0, okay? Now, from here, this is what we have. We have 3 minus lambda times negative 1 minus lambda equals 0. So negative 3, right, minus 3 lambda plus lambda squared equals 0. And so we get lambda squared minus 2 lambda minus 3 equals 0. And this right here is my characteristic equation. That's part A. Let's take a look at part B. Suppose A is the matrix, and we get 10, negative 9, 4, negative 2. And so A minus lambda I is going to be the matrix 10 minus lambda. Let's slow down. Let's do it this way. So before we do that, I'm going to do 10, negative 9, 4, negative 2. Minus, and then lambda I is lambda 0, 0, lambda. And so, therefore, A minus lambda I is the matrix 10 minus lambda. That's the first entry. Negative 9 is the second entry. And then from here, we get 4 and then negative 2 minus lambda. And so I'm going to set the determinant of A minus lambda I equal to 0. Okay? And so 10 minus lambda times negative 2 minus lambda minus negative 9 times 4 equals 0. And so if we FOIL this out, we get negative 20 minus 10 lambda plus 2 lambda plus lambda squared plus 36 equals 0, right? And so we get lambda squared minus 8 lambda. That takes care of this term and these two terms. And then it's plus 16 equals 0. And this right here is my characteristic equation. And notice how it factors really, really nicely. And that's how you do part B. Let's take a look at C. Suppose A is the matrix 0, 3, 4, 0. And then A minus lambda I is the matrix 0, 3, 4, 0 minus, and then we get the matrix lambda 0, 0, lambda. And then this is negative lambda, 3, 4, negative lambda. And I'm going to take the determinant of A minus lambda I and set it equal to 0, which tells me lambda squared minus 12 equals 0. And this is my characteristic equation. That's part C. Let's take a look at part D. Suppose A is the matrix -2, -7, 1, 2. A minus lambda I is the matrix -2, -7, 1, 2, minus the matrix lambda 0, 0, lambda. And then from here, we get -2 minus lambda, -7, 1, and then 2 minus lambda. And so I'm going to set the determinant of A minus lambda I equals 0. And so from here, we get -2 minus lambda times 2 minus lambda minus -7 times 1 equals 0. Right there. And so I'm going to take lambda squared plus 2 lambda. So lambda squared plus 2 lambda, right? That is -2 times negative lambda. And then we get negative lambda times 2, which is minus 2 lambda. And then I get -4 plus 7 equals 0. And so from here, I can say lambda squared plus 3 equals 0. And this is my characteristic equation. And that was D. E. Suppose we're given the 0 matrix. And that can happen, by the way. A minus lambda I is the 0 matrix minus lambda 0, 0, lambda. Okay? This is going to go very quick. And so this is going to be the matrix negative lambda, 0, 0, negative lambda. And so I'm going to set the determinant of A minus lambda I equals 0. And so that implies lambda squared equals 0. And that's my characteristic equation for E. F. And then we'll stop on this example. If A is the matrix 1, 0, 0, 1, and I want A minus lambda I. So this is 1, 0, 0, 1 minus lambda 0, 0, lambda. And so this is a diagonal matrix, perfect diagonal matrix. We get 1 minus lambda, 0, 0, 1 minus lambda. So I'm going to set the determinant of A minus lambda I equal to 0. And so that says 1 minus lambda squared, right, is equal to 0. And so therefore lambda squared minus 2 lambda plus 1 is 0. So, okay. That's going to do it for this video for section 5.1. And we found the characteristic equation of a given matrix. Okay, thank you.